Bismillahirrahmanirrahim. This video is about properties of limits. Let's observe the basic theorems of limits. And imagine A and C be a real number. Look at the examples that are the interpretation of theorems of limits. Example number 1. If we have limit 3 as x approaches to -1, then we will get the number 3. If limit x approaches to 4, it's simply we substitute x equal to 4, so our limits becomes 4. If we have limit 2x as x approaches to 4, simply substitute x equal to 4, so we will have 2 multiplied by 4 equal to 8. So the value of this limit is equal to 8. If we have limit square root 4x as x approaches to 1, it simply substitute x equal to 1. When we substitute x equal to 1, so we have square root of 4, then we will get the answer is equal to 2. This is continuation of basic limit theorem. Suppose that we have limit fx as x approaches to a is equal to p and limit gx x approaches to a is equal to q. Then if we have limit c fx x approaches to a, c is the constant, then we can write c and then we find limit fx x approaches to a. So limit fx equal to p, then we will get cp. And for addition and subtraction, limit fx plus minus gx as x approaches to a, we can split to limit fx plus minus limit gx. Then we can substitute for limit fx equal to p and limit gx equal to q, so we can add or subtract their answer. It's same for multiplication and division, we can split according to their function. Also for limit square root n for function fx as x approaches to a, we can write as limit fx x approaches to a and square root of n. And then we will get the answer limit fx is equal to p, then we can write square root of n for value p. Also for limit fx the power of n as x approaches to a, we can write limit fx as x approaches to a the power of n, so that we can write p the power of n. Now we look at limits of polynomial functions. If px is the polynomial function, and then we want to find limit for polynomial function px as x approaches to a, then we will get pa, means we will substitute x equal to a. Look at this example. We want to find limit for the function x squared plus 3x plus 1 as x approaches to 2. So to solve this one, we will substitute x equal to 2. So we have 2 the power of 2 plus 3 multiplied by 2 plus 1. So this one we calculate, then we will get 11. So the value of this limit is equal to 11. Here another question. We want to find limit x to the power of 3 2x plus 4. So it's simply we substitute the limit when x approaches to 1. So we simply substitute x equal to 1. So we have 1 to the power of 3 plus 2 to the power of 1 2 multiplied by 1 plus 4. So this one we will get 7. Alright, now what happens if we want to find limit for rational function? For example, we want to find limit for function 2x squared minus x minus 1 over x minus 1 as x approaches to 3. So this is the rational function. So the first thing we will substitute x equal to 3. So here we will substitute x equal to 3. Then we will get 2 multiplied by, substitute x equal to 3 here, so we get 3 square minus, substitute x equal to 3 minus 1 over 3 minus 1. So we will calculate this one. We will get 14 over 2. So then we get the answer is 7. So limit for this rational function is equal to 7. So it's same. If we want to find limit for rational function, we just substitute the value of the limits. Look at the next example. We want to find limit the same function, but we want to find limit as x approaches to 1. So first, we will substitute x equal to 1. So we have 2 multiplied by 1 square minus 1 minus 1 over 1 minus 1. So here when we calculate, we get 2 minus 1 is equal to 0. And 1 minus 1 equal to 0. So we get 0 over 0 is indeterminate form. 0 over 0 is not equal to 0. So we need to find the actual value for this limit. So what we can do is, we can try to factorize. If we have this problem, means if we get the problem of 0 over 0, then we will factorize. We will try to factorize the function and simply the equation, and then we try to solve it. So for this question, we can factorize the quadratic equation. We can factorize 2x squared minus x minus 1, so that we get 2x plus 1 multiplied by x minus 1 over x minus 1. So look here at the numerator and denominator, we have same function x minus 1 and x minus 1. So then we can cancel this one. So the rest of the function is 2x plus 1. After we simplify the equation, then we can substitute x equal to 1. We will try to substitute x equal to 1 here, so that we will get 3. So the value for the limit is equal to 3, not 0. So please remember, if we get the limit in the indeterminate form 0 over 0, then please factorize the function. Look at this example. We want to find limit for the function x squared plus 5x plus 6 over x squared plus 2x plus 2 as x approaches to negative 2. So first, we will substitute x equal to negative 2. So we have negative 2 square plus 5 multiplied by negative 2 plus 6 divided by negative 2 square plus 3 multiplied by negative 2 plus 2. So calculate this one. we will get 0 over 0. So this is the indeterminate form. So we can factorize for the function. So for this function, we have quadratic function at the both side, numerator and denominator. So we will factorize each function. So first we will factorize x squared plus 5x plus 6. We will get x plus 3, x plus 2, divide by, and then we factorize x squared plus 3x plus 2. Then we will get x plus 2 multiplied by x plus 1. So now we can simplify our function. We can cancel x plus 2 and x plus 2. So the rest is x plus 3 over x plus 1. After simplifying, then we can try to substitute x equal to negative 2. So substitute x equal to negative 2 plus 3 over negative 2 plus 1. So calculate this one, we get 1 over negative 1. So the value is negative 1. Now we look at limits involving radicals, that is square root. So look at the example. We want to find limit for the function x minus 4 over square root x minus 2 as x approaches to 4. So we have function square root x here. Firstly, to calculate the limit, we will substitute the value of x. Our value x here is 4, so we will substitute 4. X equal to 4, so we have 4 minus 4 over square root, substitute x equal to 4, so we have square root 4 minus 2. So calculate this one, we will get 0 over 0. So here we have indeterminate form 0 over 0. So if our limits involve radicals or square root, so we need to multiply by their conjugate. We will take the conjugate for the square root function. So our function here that have a square root is square root x minus 2. Look here, our square root function, square root x minus 2. So we will take their conjugate. Conjugates means square root x plus 2. Conjugate for square root x minus 2 is we replace negative to positive. So we have square root x plus 2. So we will multiply this function with square root x plus 2 in the denominator and numerator. So we can simplify this equation. For the numerator, we just multiply x minus 4 and square root x plus 2. In the denominator, multiplication of conjugate in the denominator, we will get x minus 2, minus 4, sorry. Square root x multiplied by square root x, we get x, and negative positive becomes negative, and then 2 multiplied by 2 equal to 4. So now we can simplify our equation. We can cancel x minus 4 in the numerator and the denominator. So the rest is, our function is square root x plus 2. So after simplifying, then we can try to substitute x equal to 4. So we substitute x equal to 4, we have square root 4 plus 2. So calculate this one, we will get 4. So the value of this limit is not 0, but we have 4. Look at this example. We want to find limit for the function x over square root x plus 5 minus square root 5 as x approaches to 0. So first we will substitute x equal to 0. 0 here. We have square root 0 plus 5 minus square root 5. So this one, square root 5 minus square root 5 equal to 0. So we get 0 over 0. So we have indeterminate form here. Since our question involve square root or radicals, so we need to multiply by their conjugate. So to choose the conjugate, we look at our function that have a radicals function. Here is square root x plus 5 minus square root 5. So their conjugates become square root x plus 5, and then we replace negative to positive. This is the conjugate for our square root function. So we will multiply our function with their conjugate. This one is x plus 5. We multiply their conjugate in the numerator and denominator, plus square root 5 divide by the same function, square root x plus 5 plus square root 5. Then we will multiply our function. In the numerator we have x multiplied by square root x plus 5 plus square root 5 over, then we will multiply in the denominator is multiplication of conjugate. So we multiply square root x plus 5 multiplied by square root x plus 5, we will get x plus 5, and then negative positive we have negative, and then multiply square root 5 multiplied by square root 5, we will get 5. Then simplify this one, we will get x square root x plus 5 plus square root 5 over the denominator we have x, 5 minus 5 0, so we have x. Then we can simplify our function, we can cancel x and x here, so the rest is, we have limit x approach to 0, we just have square root x plus 5 plus square root 5. After simplify, then we can try to substitute x equal to 0. So here we have square root, substitute x equal to 0, 0 plus 5 plus square root 5. So this one we get the answer is 2 square root 5.